Hello, I'm Professor Rachana Bhushan, working in this video, we are going to discuss the topic disk scheduling and operating system. So in part 1, we'll discuss some of the topics of the disk scheduling, and in second video, that is a part 2, remaining topics we'll discuss. So let's start with this. So here you can see that these are the layers of the IO system and the main functions of each layer. These all are the layers. So 5 layers are there. You can see here. So the layers of IO system and the main functions of each layers are written over there. So we will start here. Suppose any user request for some IO processing. So the IO request is given over here. So IO request, you can see here, the IO request is given to the layer, first layer, that is the topmost layer, user processes. The user processes, what it will do, it will make the IO call, format IO or spooling. Such type of IO function this layer can perform. This layer will hand over the request to the next layer, that is a device independent software, where the functions involved are naming, protection, blocking, buffering, and allocation. Okay, and then this layer will hand over the request to the bottom layer, that is a device driver. Here it will set up the device drivers and check the status of those device drivers, and then it will hand over the request to the next layer, that is the interrupt handlers. Interrupt handlers, what it will do, it will wake up the driver when IO is completed, and then here the actual hardware, and it will hand over the request to the actual hardware, that is the bottommost layer, that is actual hardware, physical thing. Okay, so here it performs the IO operation and goes back in the reverse direction, and then the IO reply is given. So these are the layers of IO systems and the main functions of each layer. So this we can call it as a user space IO software. Okay, let's continue with the disk scheduling. So disk scheduling is what? It is done by the operating system. Disk scheduling, like in operating system, we do the scheduling of the job, scheduling of the processes. Same way in for disk also, we need to do the scheduling of all the IO requests, all the requests which are coming for the disk access. We need to schedule those requests. In which order we need to schedule, in which order we need to serve those requests. So for that purpose, scheduling of these requests needs to be done. So this scheduling is done by the operating system to schedule the IO request arriving for that particular disk. So this scheduling is also known as the IO scheduling, input output scheduling. Okay. So importance of this scheduling and operating system is what? The multiple IO requests may arrive by the different processes, and only one IO request can be served at a time by the disk controller, right? So thus, the other IO requests need to wait in the waiting queue and need to be scheduled. Need to be need to wait into the waiting queue and need to be scheduled there. So two or more requests may be far from each other. So this can result in the greater disk arm movement. Suppose the one request is at the location 40 and the other request is at location 150. So there will be a greater arm movement from the location 40 to 150, right? So that is that. So hard drives are one of the slowest parts of the computer system and thus need to be accessed in an efficient manner to improve the efficient access time. To improve the efficient access time, because hard disk is one of the slowest part of our computer system and it has to be accessed in an efficient manner to improve our efficient effective access time of the particular data. Okay, so for that purpose, there are different scheduling algorithms are there. Disk scheduling algorithms are there. The four algorithms we are going to discuss. So the four algorithms are, first one is a FCFS, that is a first come first serve disk scheduling algorithm. Then second one is a SSTF, that is shortest seek time first scheduling algorithm. Then SCAN, this is the elevator algorithm, and then CSCAN, this is a circular scan algorithm. Out of these four algorithms, in this video, we'll discuss the first two algorithms, and in the next video, we'll discuss the next two algorithms, that is a scan and C-scan video. Scan and C-scan algorithms we'll see into the next video, that is a part. Okay, so we'll continue with the first two algorithms here. So the first one, that is FCFS, and the second one is SSTF. So before continuing with this scheduling algorithms, so what are the terminologies are associated, or key terms are associated with the disk scheduling that we need to understand here? Okay, so the first one is the seek time. What is the seek time or rotational latency, transfer time? So these all the key terms basically we are going to discuss on this slide. So seek time is basically the time taken to locate the disk arm to a specified track. Seek time is a time taken to locate the disk arm to a specified track where the data is to be read from or write. Where the data is to be read from. जिस particular head से हमें data track से we want to read the data or write the data to that. So the time it is taking to locate that particular arm, that is the seek time. So the disk scheduling algorithm that gives a minimum average seek time is better. So whichever algorithm is giving the minimum average seek time, that algorithm is the better algorithm. Okay. Next one is the rotational latency. This is the another key term. So rotational latency is the time taken by the desired sector of the disk to rotate into a position so that it can access the read-write heads. So the disk scheduling algorithm that gives the minimum rotational latency, that will be the better algorithm. The next one key term is the transfer time. So what is transfer time? Transfer time is basically the time to transfer the data. The time to transfer the data, it depends on the rotating speed of the disk. It depends on the rotating speed of the disk and number of bytes to be transferred at a time. So that is the transfer time. The next one is the disk response time. So response time is the average time spent by a request. Response time is the average time spent by a request waiting to perform its IO operation. So the average response time is the response time of all the requests. So we need to calculate the response time of individual requests and then find out the average of all these requests to get the average response time of all the requests. Disk access time. So disk access time can be calculated using these key terms. So disk access time is equals to here seek time, that is the time taken to locate the disk arm to the specified track, plus rotational latency, that is the time taken by the desired sector of the disk to rotate into a position so that it can access the read-write head. Okay. So first is seek time to reach to the track, rotational latency to reach to the particular head, and then transfer time, that is to actually transfer that data. So the disk access time, it is the addition of all these three. That is the seek time plus rotational latency, seek time plus rotational latency plus transfer time. That is the disk access time. The next one is the total seek time. So that is equals to total head movement into seek time. Total head movement into seek time, that will be the total seek time. Okay, so these are some key terms involved or associated with the disk scheduling. Now we continue with our scheduling algorithms here. So the first algorithm is the FCFS, that is the first come first serve disk scheduling algorithm. So FCFS is the simplest, as the name itself suggests that it is the very simplest of all the disk scheduling algorithm. In FCFS, the requests are addressed in the order they arrive in the disk. How they are addressed or they are served, the requests are served in the order they arrive in the disk. So let us understand this with the help of an example. So you can see here, the example is, suppose the order of request is 82, 170, 43, 140, 24, 16, and 190. Suppose this is the order of request is given. So this is the order of request. Now we want the current position or the initial position of the read-write head. So initial position of the read-write head or current position of the read-write head is 50. It is given here in the example. Okay. So from the diagram here, you can see now the current head position we are at here. Now from this, we'll take the first request because it is a FCFS. So whichever order is coming first will get served first. Okay, so the first request is 82. So from 50, it will go to the 82. It will traverse to 82. The next request is 170. So from 82, it will traverse to the 170. Then from 170, it will traverse to the next request, that is a 43. That is in the opposite end. Still it has to because it is FCFS. Then next one from 43, it has to traverse to the 140. It is again in the opposite end because it is FCFS. So it will traverse to 140 from the 43. Okay. Then from the 140, the next request is a 24. So it will traverse all the way from the 140 to the 24 head track, and from 24 to it will go to the 16, and from 16 it will go to the last request, that is the 190. So this is the FCFS illustration is given here through the diagrammatic. So for this example, the total head movement, total overhead movement, or total distance covered by the disk arm, we can calculate like this. You can see here the first request, that is 82, minus the initial head position minus 50, plus the second request minus the head position. In this way we need to calculate, and after calculating we can get the overall overhead movement, or the total distance covered by the disk arm is 642, is 642. For this it is too much. Okay, we'll see one more example. You can see the example of the second example. The queue, that is the queue of request, is given here. Head position, starting head position is given, it is at 53, and the head, it is moving. Illustration is also given here in the particular slide. It is moving from 53 to 98, then 98 to 183, 183 to 37, then 37 to 122, 122 to 14, then to the 124, then 65, and then to the 67. So this illustration shows the total head movement of the 640 cylinders. Okay, so this is also too much. As this is the FCFS, it doesn't see that that hierarchy from 50. Suppose the current head position is 53. So in this example, 37 is closer to that, but it will not serve the 37 because the 37 is not the first one. The first request is 98. So whichever is coming first will get served first, irrespective of the how much time it is, how much time or seek time to move from one head to the one track to the another track. So it will not look into that. So here are some of the advantages and disadvantages of the FCFS disk scheduling policy. So the advantages are every request gets a fair chance here, as in which order the order it is coming, it gets served in the same order. So every request gets a fair chance. No indefinite postponement of the IO request here. Then the disadvantages of this policy, the FCFS policy, is does not try to optimize the seek time. Yes, it is not trying to optimize the seek time. Even if suppose the first current head position is 53 and the first request is 140 and second request is suppose 55. So it will not go to 55 first because it is the first come first. So it has to go to the first request, that is a 140. So it does not try to optimize the seek time here, may not provide the best possible service. So these are some of the disadvantages of the FCFS policy. Okay, now the next scheduling algorithm, next disk scheduling algorithm we'll discuss here in this video, that is SSTF, shortest seek time first. SSTF stands for shortest seek time first. In SSTF, requests having the shortest seek time are executed first. Requests which are having the shortest seek time are executed first. So current head position, it will check the current head position and the queue of request is given. So from the queue of request, it will select the request which is having the shortest seek time. That will get served first. So here, the seek time of every request is calculated in advance. The seek time of every request is calculated in advance in the queue, and then they are scheduled according to their calculated seek time. So obviously the calculation of the seek time will require the extra time over here. Okay, as a result, the request near the disk arm will get executed first. As a result, the request, as we are calculating the seek time in advance, so the request which is near the disk arm will get executed first. So SSTF is certainly an improvement over the FCFS policy as it decreases the average response time and increases the throughput of the system. Let us understand with the help of an example in the next slide. You can see here, suppose the order of request, the same example we are continuing here for this algorithm also as in FCFS. Okay, same example is here. You can see that the head position or the total distance covered by the disk arm is reduced. So we'll first of all understand the example. Suppose the order of request is given here. You can see in the queue and the current head position of the read write head is 50. So it will first of all order this queue based on the current head position. Okay, so from 50, whichever is closer, 43 is closer. So it will go to the 43. From 43, it will go to the 24. From 24, it will go to the 16. And from 16, it will go to the next side, then opposite side. That is the first, it will serve the 82, then 140, then 170, and then 190. So in this way, it will serve the request. Okay. So the total head movement over here, the total distance covered by the disk arm is given here 50 minus 43 plus 43 minus 24. In this way, we have to sum up these all the distance, and the total distance you can see here, it is a 208, whereas in the FCFS for the same example, it was above 600. So we have reduced by almost 400 and something. Okay, second example. So second example also we are taking the same example as we have discussed the second example as in the FCFS. Same we are continuing over here as a second example in SSTF. So queue of request is given over here. Head position starting is the 53. And you can see the illustration here. And the illustration shows that the total head movement is 208, which is also in the earlier FCFS. It was about 600 and 640 something. So here also we have reduced by almost 440. So significant reduction in the total head movement. So that is the SSTF disk scheduling policy. Now we see the advantages and disadvantages of the shortest sick time first. So advantages of the shortest sick time first are the average response time is decreases here. Yes, because it responds fast. Throughput increases. Yeah, because it first calculates the, in advance it is calculating the sick time, and accordingly it is moving the head, disk head. Okay, so the throughput is increases here. Disadvantages of the shortest sick time are overhead to calculate the sick time in advance. That is one of the overhead we need to bear over here. But that overhead is okay if we compare it with the total head movement. Okay, because total head movement is significantly reduced in the SSTF. So if we compare it with that, so overhead of calculating the sick time in advance is okay. Then can cause the starvation for a request if it has a higher sick time as compared to the incoming request. Some requests may get starved because it is always preferring to go for the shortest sick time first. So if there is some request which is having the longest sick time, then that request, there are chances that that request may get starved. Then the high variance of response time as SSTF favors only some requests. Okay, so we have seen here the disk scheduling and the disk scheduling, some of the basics of disk scheduling and two algorithms of disk scheduling. Remaining two algorithms, that is a scan and C-scan algorithm, we'll see into the next video, that is the disk scheduling part 2. So thank you for the patient listening, and we'll see you again in the next part 2 of the disk scheduling video.